Hello there. Tonight you are not just listening. You are drifting. Drifting beyond the noise of the world, beyond the weight of your thoughts, and into something far older, far greater, and far more powerful than anything you've ever known. Above you, silent, endless, and watching, lies a vast ocean of stars, stretching across darkness so deep, it has no edge, no beginning, and no end you could ever reach. Billions of suns, burning quietly in the distance. Ancient light, traveling for thousands, sometimes millions of years, just to reach your eyes. And somewhere within it all, a small, quiet world where you exist, listening, breathing, aware. But the Milky Way does not speak loudly. It does not rush. It does not demand attention. Simply is unmoving, yet always in motion. Silent, yet filled with stories older than time itself. Calm, yet powerful enough to tear stars apart and shape the fate of entire galaxies. Tonight, you will not fight that vastness. You will sink into it. You will let go of urgency, of noise, of everything that feels heavy, and allow your mind to slow, to soften, to drift. Because the universe does not hurry, and neither should you. As you listen, your thoughts will begin to fade into the darkness between the stars. Your breathing will match the slow rhythm of the galaxy, and your mind will follow the same quiet path that every star, every planet, and every piece of stardust has followed for billions of years. This is not just a story. This is a journey through 100 quiet truths hidden inside the Milky Way. And as the galaxy turns, slowly, endlessly, you will drift with it, deeper, calmer, quieter, until even your thoughts become part of the silence. So close your eyes, let the universe carry you, and begin. Chapter 1: The Silent Spiral We Call Home. When you look up at the night sky on a clear, dark evening, far away from city lights, you might notice a faint, milky band stretching gently across the heavens. It looks almost like a soft brushstroke of light, a quiet river flowing through the darkness. That glowing ribbon is our home, Milky Way Galaxy. And for thousands of years, humans have gazed at it with wonder, long before understanding what it truly was. One of the first sleepy truths about the Milky Way is that what appears as a single glowing band is actually the combined light of billions of distant stars. Each tiny shimmer is a sun, many far larger and brighter than our own, yet so distant that they blur together into a soft glow. It's a reminder of how vast our galaxy truly is, so vast that even light, traveling at the fastest speed possible, takes about 100,000 years to cross from one side to the other. As you let that sink in, imagine this. If you could travel at the speed of light, the journey across the Milky Way would still take longer than all of recorded human history combined, multiplied many times over. It gives a sense of quiet scale, something almost impossible to fully grasp, yet deeply calming to think about. The Milky Way is a spiral galaxy, shaped like a cosmic whirlpool. It has graceful arms that curve outward from its center, slowly rotating over billions of years. These arms are not rigid structures but shifting regions where stars, gas, and dust gather in slightly denser patterns. Our own solar system resides in one of these arms, known as the Orion Arm, a relatively calm and quiet neighborhood, far from the crowded chaos near the center. Another gentle truth is that our galaxy is incredibly old, about 13.6 billion years. That means it formed not long after the universe itself came into existence. The stars you see tonight are part of a story that began almost at the dawn of time, evolving slowly, patiently, over unimaginable spans. At the center of the Milky Way lies something both mysterious and powerful, a supermassive black hole known as Sagittarius A. It contains millions of times the mass of our Sun, yet it remains invisible, hidden behind thick clouds of dust. Despite its immense gravity, it doesn't actively pull everything in. Instead, it sits quietly, influencing the motion of stars that orbit around it like a distant, silent anchor. Interestingly, our solar system is not racing chaotically through space. Instead, it moves in a smooth, steady orbit around the galaxy's center, completing one full journey roughly every 225 to 250 million years. This means that since the Earth formed, it has completed only about 20 galactic orbits. In a way, we are still early travelers on a very long cosmic path. Another calming thought is that the Milky Way is not static. Everything within it is in motion. Stars drifting, gas clouds swirling, clusters slowly shifting. Yet these movements are so gradual that they appear almost frozen from our perspective. The night sky you see tonight will look nearly identical thousands of years from now, a steady and comforting constant in an ever-changing universe. Within the galaxy, there are between 100 to 400 billion stars. Scientists are still refining this estimate, but even the lower number is staggering. And around many of these stars are planets, possibly even trillions of them. Some may resemble Earth, orbiting at just the right distance to support liquid water and perhaps life. The Milky Way is also filled with vast clouds of gas and dust known as nebulae. These regions are the birthplaces of stars. Over millions of years, gravity slowly pulls material together until it becomes dense enough to ignite nuclear fusion, giving birth to a new star. It's a quiet, patient process, cosmic creation unfolding in slow motion. Despite its immense size and complexity, the Milky Way is surprisingly thin. Its disk, where most of the stars reside, is only about 1,000 light-years thick. Compared to its 100,000 light-year diameter, it's like a delicate, spinning sheet, thin, yet expansive. Another soothing truth is that space within the galaxy is mostly empty. The distances between stars are so vast that collisions are extremely rare. Even if two galaxies pass through each other, like drifting clouds, their stars are unlikely to collide. This emptiness creates a sense of calm, a vast, quiet space where everything moves with gentle precision. The name Milky Way itself comes from ancient civilizations. The Greeks called it Galaxias Kyklos, meaning milky circle, inspired by its appearance in the sky. In Indian tradition, it is often associated with the celestial river, sometimes linked to the sacred Akashganga, blending science and mythology into a shared human fascination. If you could step outside the Milky Way and look back at it from a distance, you would see a glowing spiral with a bright central bulge, its arms gently winding outward. It would appear serene, almost like a cosmic flower suspended in darkness. And somewhere within one of those arms, on a small blue planet, life quietly observes it. Perhaps one of the most comforting truths is that the atoms in your body were once part of this galaxy long before you existed. Many were formed in ancient stars that lived and died billions of years ago. In a very real sense, you are made of stardust, connected to the Milky Way not just by location but by origin. As you continue to imagine this vast structure, slowly rotating, filled with light and silence, it becomes easier to let go of smaller worries. The galaxy doesn't rush. It doesn't hurry. Everything unfolds in its own time, measured in millions and billions of years. And as you rest your thoughts on that gentle motion, the Milky Way continues its quiet journey, unchanged, steady, and endlessly fascinating. As your thoughts continue to drift gently through the vastness of the Milky Way Galaxy, there is something quietly comforting about realizing how ordered it truly is beneath its immense scale. What may seem like chaos at first glance is, in reality, a slow and graceful system governed by balance, gravity guiding every star, every cloud of gas, every unseen particle along predictable paths. One of the more peaceful truths is that stars in the Milky Way do not wander aimlessly. Each one follows an orbit around the galactic center, much like planets orbit stars. These orbits can take millions or even hundreds of millions of years to complete, forming a kind of cosmic rhythm. It's not a hurried motion, but a slow, steady dance that has continued for billions of years without interruption. Our own sun is part of this dance, carrying Earth and the rest of the solar system along with it. As it moves, it gently weaves up and down through the galactic disk, like a boat rising and falling on calm waves. This vertical motion takes tens of millions of years, yet it happens so gradually that it feels almost still. Another quiet detail lies in the color of the galaxy. If you could observe the Milky Way from afar, you would notice that its spiral arms glow with a faint bluish light, while its central bulge appears warmer, more golden. This difference tells a story. Blue light comes from younger, hotter stars, while the golden glow comes from older stars that have cooled over time. In this way, the galaxy reveals its age patterns through subtle hues, like rings in a tree. Hidden within the spiral arms are long, dark lanes of dust. These dust clouds block visible light, creating shadowy streaks that cut across the glowing background. But within these dark regions, something remarkable is happening. They are not empty or lifeless. Instead, they are full of potential, quietly forming new stars that will one day shine. The Milky Way also contains star clusters, groups of stars that were born together and still travel through space as a family. Some of these clusters are open and loosely bound, while others, known as globular clusters, are tightly packed and incredibly old. These globular clusters orbit the galaxy like ancient guardians, some nearly as old as the galaxy itself. Floating between the stars is something almost invisible: interstellar gas. Though incredibly thin, this gas plays a crucial role in the life cycle of the galaxy. It is the raw material from which stars are formed, and when stars die, they return enriched material back into this space, continuing the cycle. It is a quiet exchange, happening endlessly across the galaxy. Another calming truth is that sound, as we know it, does not travel through the Milky Way. Space is too empty to carry vibrations the way air does on Earth. So despite all the movement, the galaxy exists in complete silence. Even the most powerful stellar explosions unfold without a sound, making the Milky Way a place of profound quiet. There is also a gentle sense of perspective in knowing that we cannot see the full shape of our galaxy from within it. We are like observers inside a vast forest, able to see individual trees but not the entire landscape at once. Much of what we know about the Milky Way comes from careful observation, mapping, and inference, built slowly over decades of study. One fascinating detail is that the Milky Way is part of a small group of galaxies known as the Local Group. Among them is our nearest large neighbor, Andromeda Galaxy. Though it appears as a faint smudge in the night sky, it is actually on a slow course toward us. But there is no need for concern. This encounter will not happen for about 4 billion years, and even then, It will unfold over an immense span of time, more like a merging of gentle currents than a collision. Within the Milky Way, there are also regions of intense energy, places where stars are born rapidly or where massive stars end their lives in brilliant explosions known as supernovae. These events release enormous amounts of energy, briefly outshining entire galaxies. Yet even these powerful moments are part of the galaxy's natural rhythm, contributing to the creation of new elements and future stars. The galaxy is also threaded with magnetic fields, subtle and invisible forces that influence the motion of charged particles. These fields stretch across vast distances, shaping the behavior of cosmic rays and interstellar gas. Though we cannot see them, they are an essential part of the galaxy's structure. Another truth, almost poetic in nature, is that light from distant parts of the Milky Way takes thousands of years to reach us. When you look at certain stars, you are seeing them as they were long ago. Some of that light began its journey before human civilization even existed. In a way, the night sky is a window into the past. There are also rogue stars, stars that move through the galaxy at unusually high speeds, sometimes ejected from their original systems by gravitational interactions. These stars travel alone, drifting through space like quiet wanderers, carrying their own stories across the galaxy. Despite its immense size, the Milky Way is only one of hundreds of billions of galaxies in the observable universe. Yet it is the only one we have ever known directly, the only one we call home. And within it, on a small planet orbiting an ordinary star, consciousness has emerged, able to observe, to wonder, and to reflect. Perhaps the most soothing realization of all is that the Milky Way does not demand anything from us. It simply exists, vast, silent, and patient. Its stars will continue to shine, its arms will continue to turn, and its story will continue to unfold whether we watch or not. And yet, here you are, quietly aware of it. As your thoughts slow, you can imagine the galaxy above you, stretching endlessly, its billions of stars glowing softly in the dark. Nothing is rushed. Nothing is urgent. Everything moves at its own pace, guided by forces that have been in place since the beginning of time. In this immense and gentle system, there is a kind of peace, a reminder that not everything needs to be hurried, that some things are meant to unfold slowly over vast stretches of time. And as the Milky Way continues its silent rotation, you can simply rest, letting your mind drift along with it, carried by the quiet rhythm of the universe itself. Chapter 2: The Hidden Heart of the Galaxy. At the very center of the Milky Way Galaxy lies a region so dense, so luminous, and yet so deeply hidden that for most of human history, it remained completely unknown. When you look up at the night sky, you are not seeing this central heart directly. Thick clouds of cosmic dust stretch across our line of sight, gently veiling the galaxy's core like a curtain. And behind that curtain, something extraordinary quietly resides. One of the most fascinating truths about this hidden heart is that it is incredibly crowded. While our solar system exists in a relatively calm and spacious region, the galactic center is packed with stars, millions of them within a very small volume of space. If you were somehow able to stand on a planet near the center, the night sky would never truly be dark. Stars would fill the heavens in every direction, shining so brightly that darkness itself would feel unfamiliar. At the core of this dense region sits a powerful and mysterious object known as Sagittarius A. This is not just any black hole. It is a supermassive one, containing about 4 million times the mass of our Sun. And yet, despite its immense gravitational pull, it does not behave like a cosmic vacuum cleaner. It does not roam or consume everything around it. Instead, It remains anchored at the center, quietly shaping the motion of stars that orbit it. The presence of Sagittarius A was not discovered by directly seeing it, but by carefully observing the movement of stars nearby. Scientists noticed that certain stars were orbiting an invisible point with incredible speed, tracing tight, elongated paths. Only something extremely massive and compact could produce such motion. Over time, this evidence revealed the existence of the black hole, hidden but undeniable. Another gentle truth is that black holes, despite their reputation, are not destructive in the way they are often imagined. If our sun were replaced by a black hole of equal mass, Earth would continue orbiting just as it does now. It is not the nature of the object, but its mass and proximity that determine its influence. In the case of Sagittarius A, we are far enough away, about 26,000 light-years, that its effects on us are minimal. Surrounding the galactic center is a region known as the bulge, a spherical concentration of older stars. These stars are among the oldest in the galaxy, some nearly as old as the Milky Way itself. They glow with a warm golden light, a quiet contrast to the younger, bluer stars found in the spiral arms. This difference in color tells a story of time, of generations of stars that have lived and evolved over billions of years. Within this central region, there are also vast streams of gas and dust, slowly moving under the influence of gravity. Occasionally, some of this material drifts too close to Sagittarius A. When it does, it begins to spiral inward, forming what is known as an accretion disk, a swirling ring of matter that heats up as it falls. This process can release bursts of energy, briefly illuminating the region with intense radiation before fading again into quiet. Another calming detail is that the galactic center is not chaotic in a violent sense, but rather dynamic in a structured way. Stars orbit in predictable paths, gas clouds follow gravitational flows, and even the interactions between objects occur over long timescales. It is a place of motion, but not of sudden disruption, a slow and steady system governed by balance. There are also unusual stars near the center, some of which orbit Sagittarius A at astonishing speeds, thousands of kilometers per second. These stars complete their orbits in just a few decades, compared to the Sun's 225 million-year journey around the galaxy. Observing these stars has allowed scientists to test the predictions of general relativity, confirming how gravity behaves in extreme conditions. Interestingly, the galactic center is also a source of radio waves and X-rays, which can pass through the dense dust clouds that block visible light. By observing these wavelengths, astronomers have been able to map the structure of the core, revealing its complexity and activity without ever seeing it directly in visible light. Another truth, almost poetic in nature, is that the center of the galaxy acts like a kind of anchor. Its immense mass helps hold the entire structure of the Milky Way together, guiding the motion of stars across vast distances. Without this central mass, the galaxy would not have the same shape or stability. Despite all this activity, the center of the Milky Way is not unusually active compared to some other galaxies. In certain galaxies, central black holes actively consume large amounts of matter, producing enormous jets of energy that extend far beyond the galaxy itself. Our galaxy, by comparison, is relatively quiet. Sagittarius A is currently in a low-energy state, gently interacting with its surroundings rather than dramatically consuming them. Another soothing perspective is that even the most energetic events near the galactic center take place far beyond any human timescale. What may seem like a sudden burst of energy could actually unfold over years or decades. From our vantage point, everything remains distant and calm. There are also magnetic filaments, long thread-like structures near the center that stretch across dozens of light years. These filaments are not fully understood, but they appear to be shaped by strong magnetic fields, adding another layer of quiet complexity to the region. As you imagine this hidden heart, surrounded by layers of dust and distance, it becomes clear that much of the Milky Way remains unseen to the naked eye. And yet, through careful observation and patient study, humanity has begun to uncover its secrets, piece by piece. The idea that something so massive and powerful can remain so well concealed is, in itself, a calming thought. It reminds us that the universe is not always obvious. Some of its most profound features exist quietly, waiting to be discovered. And as you let your mind drift toward this distant center, 26,000 light years away, you can picture it not as something threatening, but as something steady and enduring. A quiet heart, beating slowly at the core of a vast and gentle galaxy. As your thoughts continue to drift toward the distant center of the Milky Way Galaxy, it becomes easier to imagine that hidden region not as something chaotic, but as something deeply structured, almost like the quiet core of a vast, slowly turning clock. Everything there moves with purpose, guided by gravity, unfolding over timescales so long that even the most dramatic changes feel gentle. One of the more subtle truths about the galactic center is that it is constantly changing, yet in ways that are almost impossible to notice in a single human lifetime. Stars are born, stars drift, and stars fade. But these processes occur so gradually that the overall appearance remains nearly the same for thousands of years. It is a place of motion, but not of urgency. Near Sagittarius A, there exists a cluster of stars known as the S-stars. These stars follow extremely tight and fast orbits around the black hole, tracing paths that resemble elongated loops. One of them, often referred to as S2, completes an orbit in just about 16 years. Watching its motion has allowed astronomers to confirm, with remarkable precision, how gravity behaves under extreme conditions. And yet, even these fast-moving stars are part of a larger stillness, tiny motions within an immense and quiet system. Another calming truth is that the energy near the galactic center is not constant. Sagittarius A occasionally releases small flares of radiation, likely caused by bits of gas falling inward. These flares are brief and irregular, like quiet flickers rather than sustained outbursts. Most of the time, the black hole remains dormant, almost peaceful in its inactivity. Surrounding the center is a dense environment of molecular clouds, vast collections of gas that can span dozens of light years. These clouds are cold and dark, yet they hold the potential for future star formation. Occasionally, gravitational disturbances compress parts of these clouds, triggering the slow birth of new stars. Even in the galaxy's busiest region, creation continues quietly. There is also a fascinating structure known as the nuclear star cluster, a compact region filled with millions of stars packed closely together. This cluster is distinct from the broader bulge and is one of the densest stellar environments in the galaxy. Despite this density, collisions between stars remain rare due to the immense distances between them, reminding us once again how much empty space exists even in crowded regions. Another gentle detail lies in the way light behaves near the center. Because of the intense gravity of Sagittarius A, light passing close to it can be bent, a phenomenon known as gravitational lensing. This effect allows astronomers to observe stars that would otherwise be hidden, as their light curves around the massive object. It is a subtle bending, a quiet distortion that reveals more than it conceals. The galactic center is also home to high-energy particles known as cosmic rays. These particles move at nearly the speed of light, traveling across the galaxy and occasionally reaching Earth. While they sound intense, Earth's atmosphere protects us from their effects, allowing them to pass unnoticed. It's another reminder that even powerful phenomena can exist without disturbing our calm. Far above and below the galactic plane, extending outward from the center, are enormous structures known as the Fermi bubbles. These giant lobes of gamma-ray emission stretch tens of thousands of light-years into space. Scientists believe they may be the result of past activity from Sagittarius A, perhaps from a time when it was more active. Today, they remain as quiet echoes, evidence of ancient events that have long since settled into stillness. Another truth, both humbling and soothing, is that we will never physically visit the galactic center. The distance is simply too great and the environment too extreme for current technology. And yet, through observation and imagination, we are still able to understand it, to map it, and to feel connected to it. Knowledge becomes a bridge across that vast distance. The center of the galaxy also rotates just like the rest of the Milky Way. However, its rotation is more complex, influenced by the dense concentration of mass and the interactions between stars and gas. This creates a kind of layered motion, different regions moving at different speeds, yet all part of the same overall structure. There are also hints that smaller black holes may exist near the center, remnants of massive stars that ended their lives long ago. These stellar mass black holes quietly drift through the region, largely undetectable unless they interact with nearby matter. They are like hidden shadows within an already hidden place. Another calming perspective is that, despite all the complexity, the laws of physics remain consistent. Gravity, motion, energy, all behave according to the same principles that apply here on Earth. This consistency creates a sense of order, a reminder that even the most distant and mysterious parts of the universe are governed by familiar rules. The light we receive from the galactic center today began its journey around 26,000 years ago. At that time, early humans were creating cave paintings, learning to survive and adapt. While life on Earth has changed dramatically since then, the light from the center has been traveling steadily toward us, unchanged, carrying with it a snapshot of the past. There is also a quiet beauty in knowing that the center of the galaxy is not something we need to fully understand to appreciate. Its existence alone, massive, distant, and hidden, is enough to inspire a sense of wonder. It reminds us that the universe holds layers of mystery, some of which may never be completely revealed. As you let your thoughts settle, you can imagine that distant core as a steady presence, a glowing, unseen heart around which everything gently turns. It does not rush. It does not demand attention. It simply exists, holding the galaxy together with quiet strength. And in that stillness, there is something deeply comforting. The Milky Way continues its slow rotation, stars tracing their paths, gas clouds drifting, and at the center, Sagittarius remains, silent, unseen, yet profoundly important. It is a reminder that even in the vastness of space, there are centers, anchors, places of quiet balance. And as you rest your mind on that idea, the galaxy feels less like something distant and overwhelming, and more like something calm and continuous. An endless, gentle motion that carries everything along with it. Chapter 3: Stars, Dust, and the Art of Creation. Drifting gently outward from the hidden heart of the Milky Way Galaxy, your thoughts begin to settle into the quieter regions where creation happens. Not suddenly, not violently, but slowly, patiently, almost like a breath drawn across millions of years. Here, in the soft darkness between stars, the raw materials of the universe gather, waiting for gravity to begin its silent work. One of the most soothing truths about the Milky Way is that stars are not permanent. They are born, they live, and they eventually fade away, making space for new stars to emerge. This continuous cycle of creation and transformation gives the galaxy a kind of quiet rhythm, like waves rising and falling on an endless ocean. It all begins with vast clouds of gas and dust known as nebulae. These clouds can stretch across hundreds of light years, yet they are so diffuse that if you were inside one, you might barely notice it. Over time, small variations in density cause certain regions to gather more material. Gravity begins to pull these regions inward, slowly compressing them. As this process continues, the material becomes denser and warmer. Eventually, a core forms, a protostar. At this stage, the future star is not yet shining through nuclear fusion, but it is already glowing faintly from the heat generated by compression. This phase can last for millions of years, a slow and steady buildup toward ignition. When the core temperature becomes high enough, something remarkable happens. Hydrogen atoms begin to fuse together, forming helium and releasing enormous amounts of energy. This is the moment a star is born. The light that emerges from this process can travel across the galaxy, eventually reaching distant worlds. One of the more comforting aspects of this process is its predictability. The same basic steps occur everywhere in the galaxy, governed by the same physical laws. Whether a star forms in a quiet corner of the Orion Arm or deep within a distant spiral arm, the process remains the same, simple, consistent, and reliable. Another gentle truth is that not all stars are alike. Some are small and cool, glowing softly for trillions of years. Others are massive and bright, burning their fuel quickly and living much shorter lives. These differences create a rich diversity within the galaxy, a variety that adds depth and texture to the night sky. Among the most beautiful star-forming regions is the Orion Nebula, a place where new stars are actively being born. Though it appears as a faint patch to the naked eye, telescopes reveal a vibrant landscape of glowing gas and young stars, each at a different stage of formation. Inside these nebulae, dust plays an important role. These tiny particles, made of elements like carbon, silicon, and oxygen, help cool the gas, allowing it to collapse more easily under gravity. Without dust, star formation would be far less efficient. In a quiet way, these microscopic grains help shape the entire galaxy. Another calming detail is that star formation is not constant everywhere. It occurs in waves, often triggered by events such as the shock waves from nearby supernovae. When a massive star ends its life in an explosion, it sends out ripples of energy that can compress nearby gas clouds, gently encouraging new stars to form. In this way, even endings become beginnings. As stars begin to shine, they often form in clusters. These clusters are like families, groups of stars that share a common origin. Over time, many of these clusters slowly disperse, their stars drifting apart and becoming part of the wider galaxy. But for a while, they remain together, moving through space as a quiet, unified group. The light from young stars can also shape their surroundings. Intense radiation pushes away nearby gas and dust, carving out cavities within the nebula. This creates intricate structures, pillars, filaments, and glowing edges that give nebulae their striking appearance. Another peaceful truth is that the elements needed for life are created within stars themselves. Through nuclear fusion, stars produce heavier elements like carbon, oxygen, and iron. When these stars eventually die, they release these elements back into the galaxy, enriching the interstellar medium. Over time, this material becomes part of new stars, planets, and perhaps even living beings. This means that every atom in your body was once part of a star. The carbon in your cells, the oxygen you breathe, even the calcium in your bones, all were formed in ancient stellar furnaces. It's a quiet connection, linking you directly to the processes unfolding across the Milky Way. Another fascinating detail is that some stars form with planetary systems right from the beginning. As the protostar forms, a disk of material surrounds it. Within this disk, dust particles collide and stick together, gradually forming larger bodies. Over millions of years, these can grow into planets, moons, and other structures. The formation of stars is not a fast or dramatic event. It is a slow gathering, a gradual warming, a steady transition from darkness to light. And even after a star is born, it continues to evolve, changing over billions of years. There are also regions in the galaxy where star formation has nearly stopped. These areas are filled with older stars, their youthful gas clouds long gone. In contrast, other regions remain active, glowing with the energy of newly formed stars. This variation creates a dynamic balance across the galaxy. Another calming perspective is that star formation has been happening for nearly the entire lifetime of the Milky Way. From its earliest days to the present moment, new stars have continued to emerge. Even now, as you read this, somewhere in the galaxy, a new star is quietly igniting. The scale of these processes can feel immense, yet they unfold in a way that is almost meditative. There is no rush, no urgency, just a steady progression guided by gravity and time. As you imagine these vast clouds slowly collapsing, stars gradually lighting up, and clusters gently drifting apart, it becomes easier to feel the calm rhythm of the galaxy. Creation is not sudden here. It is patient, continuous, and deeply connected to everything around it. And as the Milky Way continues to turn, these processes carry on, quietly, endlessly, filling the galaxy with light, one star at a time. As your thoughts continue to drift through the quiet stellar nurseries of the Milky Way Galaxy, it becomes clear that creation here is not a single moment, but an unfolding story, one that stretches across millions of years, shaped by gentle forces and subtle changes. Nothing is rushed. Every star, every grain of dust, follows its own quiet path toward becoming something new. After a star is born, it enters a long and stable phase known as the main sequence. During this time, it shines steadily, balancing the inward pull of gravity with the outward pressure from nuclear fusion. Our own sun is currently in this stage, calmly converting hydrogen into helium, releasing light and warmth that sustain life on Earth. This balance can last for billions of years, making it one of the most peaceful and enduring phases in a star's life. Another soothing truth is that stars do not exist in isolation. Many are part of binary or multiple star systems, where two or more stars orbit each other in a slow, graceful dance. These systems can create unique environments, where the light of one star blends with another, casting complex and ever-changing patterns across any nearby planets. In some regions of the galaxy, star formation produces massive stars, giants that burn brightly but live short lives. These stars emit intense radiation and powerful stellar winds, shaping their surroundings in dramatic ways. Yet even their intensity unfolds gradually, over millions of years, never in a sudden or chaotic burst. As these massive stars age, they begin to change. Their cores become unstable, and they expand into red supergiants, glowing with a deep, warm light. Eventually, they reach the end of their lives in a supernova explosion, an event so bright it can briefly outshine an entire galaxy. But even this dramatic ending is part of a larger cycle, releasing heavy elements back into space, where they will one day become part of new stars and planets. Not all stars end their lives this way. Smaller stars, like our Sun, follow a gentler path. As they run out of fuel, they expand into red giants, shedding their outer layers into space. What remains is a dense core known as a white dwarf, slowly cooling over billions of years. These remnants glow faintly, like embers left behind after a long, steady fire. Another calming detail is that the dust released by dying stars does not simply drift aimlessly. It becomes part of the interstellar medium, mixing with existing gas and dust, gradually contributing to the formation of new nebulae. In this way, the galaxy recycles its material, ensuring that nothing is truly lost, only transformed. There are also regions where star formation occurs in waves, triggered by the movement of spiral arms. As these arms rotate through the galaxy, they compress gas clouds, encouraging new stars to form. This creates a pattern where star formation is more active in certain areas, giving the spiral arms their bright, glowing appearance. One of the more fascinating truths is that the process of planet formation begins almost simultaneously with star formation. Around young stars, disks of gas and dust spin slowly, gradually flattening into a thin plane. Within these disks, tiny particles collide and stick together, forming larger and larger structures. Over time, these can become planets, moons, and even entire planetary systems. Another gentle truth is that these processes are incredibly common. Across the Milky Way, countless stars are forming, each with the potential to host planets. Some of these planets may resemble Earth, orbiting at just the right distance from their stars to allow liquid water to exist. Though we have only discovered a fraction of them, the possibilities are vast. The light from young stars often illuminates the surrounding dust, creating reflection nebulae soft, glowing regions that shine not from their own energy, but from the light of nearby stars. These nebulae appear in delicate shades of blue, scattering light in a way that feels almost dreamlike. There are also emission nebulae, where gas is energized by nearby stars, causing it to glow in vivid colors such as red and pink. These colors come from specific elements: hydrogen, oxygen, and sulfur, each emitting light at characteristic wavelengths. Together, they create some of the most beautiful structures in the galaxy. Another peaceful perspective is that even the most complex structures in the Milky Way arise from simple principles: gravity, motion, and energy. There is no need for external guidance or intervention. The galaxy shapes itself, slowly and naturally, following the same laws everywhere. Over time, star formation gradually changes the composition of the galaxy. Early stars were made mostly of hydrogen and helium, but as generations of stars lived and died, heavier elements became more abundant. This process, known as chemical enrichment, has made it possible for planets like Earth to form. Another quiet truth is that the Milky Way is still forming stars today. Though the rate has slowed compared to its early years, the process continues, adding new light to the galaxy. Somewhere, deep within a distant nebula, a new star is beginning to shine, its light just starting a journey that may last billions of years. There is also a sense of balance in the way creation and destruction coexist. Stars are born from the remnants of older stars, and in turn, they will one day contribute to future generations. It is a cycle without a true beginning or end, a continuous flow of matter and energy. As you imagine these processes unfolding, dust gathering, stars igniting, planets forming. It becomes easier to feel the gentle rhythm of the galaxy. Everything moves forward, but nothing is hurried. Each stage leads naturally to the next, guided by forces that have remained unchanged since the beginning of time. And within this vast system, your own existence becomes part of the story. The atoms that make up your body were once part of this cycle, shaped by stars that lived long before Earth existed. In a quiet way, you are connected to every nebula, every star, every cloud of dust in the Milky Way. As the galaxy continues its slow rotation, these processes carry on, steady, patient, and endless. New stars will continue to form, old stars will fade, and the cycle of creation will never truly stop. And as your thoughts settle into that rhythm, the Milky Way feels less like something distant and more like something deeply familiar. A place where everything is connected, quietly evolving, one moment at a time. Chapter 5: The Dark Matter Mystery. As your thoughts drift deeper into the vastness of the Milky Way Galaxy, you begin to notice something quietly puzzling. Everything you've imagined so far, the stars, the glowing nebulae, the soft dust clouds, makes up only a small fraction of what actually exists. Beneath the visible beauty of the galaxy lies something hidden, something that cannot be seen, touched, or directly observed, and yet it is everywhere. This unseen presence is known as dark matter. One of the most calming, yet mysterious truths about dark matter is that it does not emit or reflect light. It does not glow like stars or shimmer like gas clouds. It simply exists quietly, influencing the galaxy through gravity. And even though we cannot see it, its presence is undeniable. The discovery of dark matter did not come from direct observation, but from noticing something unusual in the way galaxies move. When scientists studied the rotation of galaxies, including the Milky Way, they found that stars far from the center were moving much faster than expected. Based on visible matter alone, these stars should have drifted away into space. But they didn't. Instead, they continued orbiting steadily, as if held in place by an invisible force. This led to the realization that there must be additional mass that we cannot see, providing the extra gravity needed to keep everything together. Another gentle truth is that dark matter forms a vishal halo around the Milky Way, extending far beyond the visible disk. This halo is not dense like a solid object, but rather diffuse, spread out over enormous distances. It surrounds the galaxy like an invisible cocoon, quietly shaping its structure. Without dark matter, the Milky Way as we know it might not exist. The visible matter alone would not have enough gravity to hold the galaxy together. Stars would drift apart, and the elegant spiral structure would slowly unravel. In this way, dark matter acts as a kind of hidden framework, providing stability without ever revealing itself directly. Another soothing perspective is that dark matter does not interact with ordinary matter in the way we might expect. It does not collide, does not form atoms, and does not create light. It passes through normal matter almost effortlessly, like a silent shadow moving through space. Even now, as you sit quietly, countless dark matter particles may be passing through your body every second, completely unnoticed, leaving no trace. It sounds extraordinary, yet it is a gentle reminder of how much of the universe exists beyond our senses. Scientists believe that dark matter makes up about 85% of all matter in the universe. This means that everything we can see, stars, planets, galaxies, represents only a small portion of what truly exists. The majority remains hidden, shaping the cosmos from behind the scenes. Another calming detail is that dark matter is not unique to the Milky Way. It is present in all galaxies, forming halos that influence their motion and structure. It also plays a role on even larger scales, helping to shape clusters of galaxies and the vast cosmic web that connects them. The nature of dark matter remains one of the greatest mysteries in modern science. Many theories have been proposed, suggesting that it could be made of new, undiscovered particles. Experiments around the world are searching for signs of these particles, using sensitive detectors placed deep underground to shield them from interference. Yet, despite decades of research, dark matter has not been directly detected. And still, its presence is felt everywhere, through the motion of stars, the bending of light, and the structure of the universe itself. Another fascinating truth is that dark matter does not clump together in the same way as ordinary matter. It forms large, diffuse structures rather than dense objects like stars or planets. This difference helps explain why it remains invisible. It never becomes concentrated enough to emit light. There is also a quiet beauty in the idea that something so important can remain unseen. Dark matter reminds us that the universe is not limited to what we can observe. There are layers of reality that exist beyond our current understanding, waiting to be discovered. The Milky Way moves through this dark matter halo, its stars embedded within it, guided by its gravitational influence. Every orbit, every motion, every gentle rotation is shaped not just by what we can see, but by what we cannot. Another gentle perspective is that dark matter has been present since the early universe. It played a crucial role in the formation of galaxies, providing the gravitational seeds around which visible matter could gather. Without it, the universe might look very different, less structured, less defined. As you imagine this invisible presence surrounding the galaxy, it becomes less unsettling and more calming. It is not something to fear, but something that quietly supports the structure of the cosmos. It does not interfere or disrupt. It simply exists, steady and constant. There are also moments when dark matter reveals itself indirectly through a phenomenon known as gravitational lensing. When light from distant objects passes near a region rich in dark matter, it bends slightly, creating distortions that can be observed. These distortions act like footprints, showing where dark matter must be. Another truth is that the Milky Way's halo of dark matter extends far beyond what we can see, possibly reaching hundreds of thousands of light-years into space. It is vast, quiet, and almost impossible to fully comprehend. And yet, despite its mystery, dark matter fits seamlessly into the story of the galaxy. It does not disrupt the calm flow of motion or the gentle rhythm of star formation. Instead, it enhances it, providing the stability needed for everything else to exist. As your thoughts settle on this unseen presence, you may begin to feel a sense of quiet wonder. The universe is not just what is visible, it is also what is hidden, what is felt but not seen. And within the Milky Way, dark matter continues its silent work, shaping the galaxy from within, holding it together, guiding its motion, all without ever revealing itself. As your thoughts continue to drift through the quiet structure of the Milky Way Galaxy, the presence of dark matter begins to feel less like a mystery to solve and more like a quiet companion. Something always there, shaping the galaxy without ever demanding attention. One of the most calming truths about dark matter is that, despite how little we understand it, its effects are remarkably consistent. Across the Milky Way and beyond, it behaves in predictable ways, influencing motion through gravity alone. It does not fluctuate or behave erratically. Instead, it provides a steady, invisible framework that helps everything else remain in balance. If you could somehow see the Milky Way's dark matter halo, it would appear as a vast, faint sphere surrounding the galaxy, extending far beyond the visible stars. This halo would not glow or shimmer. It would simply be there, quietly holding the galaxy together. The stars we see are only the bright center of a much larger, hidden structure. Another gentle detail is that dark matter moves differently from ordinary matter. While stars and gas clouds can collide, merge, and interact, dark matter particles pass through each other without resistance. This means that even when galaxies interact or merge, their dark matter halos can overlap smoothly, continuing their motion without disruption. This behavior has been observed in large-scale cosmic events, where clusters of galaxies pass through one another. The visible matter, gas and stars, interacts and slows down, but the dark matter continues almost unaffected, revealing itself through its gravitational influence. It is a quiet separation, a subtle demonstration of its unique nature. Another calming truth is that dark matter helps maintain the shape of the Milky Way. Without it, the outer regions of the galaxy would not have enough gravitational support to remain bound. Stars at the edges would drift away over time, and the elegant spiral structure would slowly dissolve. In this way, dark matter acts like a gentle anchor, keeping everything connected. There is also a quiet elegance in how dark matter influences the formation of galaxies. In the early universe, small fluctuations in dark matter density created regions where gravity was slightly stronger. These regions attracted ordinary matter, leading to the formation of the first stars and galaxies. Without dark matter, this process would have been much slower and less efficient. Another soothing perspective is that dark matter does not interfere with the processes we observe. It simply supports them. Star formation, galactic motion, and cosmic evolution all proceed as they would, but with the added stability provided by this unseen mass. It is like a foundation beneath a building, rarely noticed but essential. Scientists have proposed several candidates for what dark matter might be. One possibility is a type of particle known as a WIMP, short for weakly interacting massive particle. These hypothetical particles would have mass but interact very weakly with normal matter, making them extremely difficult to detect. Another possibility involves particles called axions, which are even lighter and more elusive. Experiments are ongoing to search for these particles, using highly sensitive upkaran placed in controlled environments. Yet so far, dark matter remains undetected directly, continuing to exist just beyond our reach. There is also a more unconventional idea that our understanding of gravity itself might need adjustment. Some theories suggest that what we attribute to dark matter could be explained by modifications to gravitational laws on large scales. While these ideas are still debated, they reflect the depth of the mystery. Another gentle truth is that, despite its unknown nature, dark matter does not pose any danger. It does not interact with our bodies, does not affect our daily lives, and does not change suddenly. It has been present throughout the history of the universe, quietly influencing its structure without causing harm. The Milky Way's dark matter halo also contains smaller clumps, or subhalos, which may host faint dwarf galaxies. These tiny galaxies orbit the Milky Way, often invisible to the naked eye but detectable through careful observation. They are like small companions, moving within the larger halo. Another calming detail is that dark matter helps explain the motion of satellite galaxies. Without its additional gravitational pull, these smaller galaxies would not remain bound to the Milky Way. Their orbits, like those of stars, are shaped by both visible and invisible forces. There is also a quiet beauty in the idea that most of the universe is hidden. It suggests that there is still much to learn, much to discover. The Milky Way is not fully known, and perhaps it never will be. And yet, that uncertainty adds depth to its story, making it even more fascinating. As you imagine this vast halo surrounding the galaxy, extending far into the darkness, it becomes less of a mystery and more of a presence. Steady, silent, and essential. It does not demand attention, but it is always there, shaping everything from behind the scenes. Another peaceful perspective is that dark matter connects the Milky Way to the larger structure of the universe. It forms part of the cosmic web, a vishal network of filaments and nodes that link galaxies across immense distances. Within this web, galaxies are not isolated, but part of a larger, interconnected system. And yet, within all this complexity, the Milky Way remains calm. Its stars continue their orbits, its nebulae continue to form new stars, and its dark matter halo continues to hold everything together. As your thoughts slow, you can imagine the galaxy not just as a collection of visible light, but as a layered structure, seen and unseen, known and unknown. And within that structure, everything works together quietly and seamlessly. The stars shine, the galaxy turns, and dark matter remains. Silent, invisible, and endlessly present. And in that quiet presence, there is a kind of peace. A reminder that even what we cannot see can still provide stability, balance, and continuity. Chapter 6: The Lives and Deaths of Stars. As your thoughts drift gently through the vast expanse of the Milky Way Galaxy, you begin to notice that every point of light in the night sky carries a story. A beginning, a long middle, and eventually, an ending. Stars may appear constant and unchanging, but in truth, they are always evolving, quietly moving through different stages of life over spans of time so long that they feel almost eternal. One of the most soothing truths about stars is that their lives are governed by balance. From the moment a star is born, it exists in a steady state between two forces: gravity pulling inward and energy pushing outward. This balance allows stars to shine consistently for millions or even billions of years, creating a sense of calm stability within the galaxy. The life of a star begins in regions like the Orion Nebula, where clouds of gas slowly collapse under gravity. As the material gathers, it forms a protostar, gradually heating up until nuclear fusion begins. Once fusion starts, the star enters its main sequence phase, the longest and most stable part of its life. During this phase, the star converts hydrogen into helium in its core, releasing energy in the form of light and heat. This process is remarkably efficient and can continue for billions of years. Our own sun, for example, has been shining steadily for about 4.6 billion years, and is expected to continue doing so for several billion more. Another calming detail is that a star's mass determines its entire life story. Smaller stars burn their fuel slowly, glowing gently for trillions of years. Larger stars burn much more quickly, shining brighter but living shorter lives. This variation creates a quiet diversity within the galaxy, where different stars exist at different stages of their journey. As a star like the Sun ages, it eventually begins to run low on hydrogen fuel in its core. When this happens, the balance between gravity and energy shifts. The core contracts, heating up further while the outer layers expand. The star becomes a red giant, growing much larger and cooler in appearance. This transformation is not sudden or violent. It happens gradually over millions of years. The star swells outward, its light becoming softer and redder, creating a gentle transition from one phase to the next. Another soothing truth is that even as stars approach the end of their lives, they continue to create. In their later stages, stars begin to fuse heavier elements in their cores: carbon, oxygen, and beyond. These elements are essential for the formation of planets and, eventually, life. For stars similar in size to the Sun, the final stages are relatively calm. After expanding into a red giant, the star sheds its outer layers, creating a glowing shell of gas known as a planetary nebula. At the center remains a white dwarf, a dense, slowly cooling remnant that will fade over billions of years. Another gentle perspective is that nothing in a star's life is wasted. The material released during its final stages becomes part of the interstellar medium, contributing to future generations of stars. In this way, each star leaves behind a legacy, continuing the cycle of creation. Larger stars, however, follow a different path. Their greater mass allows them to fuse heavier elements more rapidly, leading to a more dramatic ending. As they exhaust their fuel, their cores collapse suddenly, triggering a supernova explosion. This explosion releases an immense amount of energy, briefly outshining entire galaxies. Yet even this dramatic event unfolds as part of a natural process. The supernova disperses heavy elements into space, enriching the surrounding material. These elements, iron, gold, and others, become part of new stars, planets, and even living organisms. Another calming truth is that supernovae are rare within any given region of the galaxy. They occur perhaps once every few decades in the Milky Way, often far from our location. Their effects are localized, and their role is primarily creative rather than destructive. After a supernova, what remains depends on the original mass of the star. Some leave behind neutron stars, extremely dense objects composed almost entirely of neutrons. Others collapse further, forming black holes. These remnants continue to exist quietly, influencing their surroundings through gravity. There is also a sense of continuity in the way stars evolve. The processes that govern their lives have remained unchanged for billions of years. Every star follows the same fundamental rules, creating a sense of order and predictability across the galaxy. Another soothing detail is that many of the stars you see in the night sky are still in their main sequence phase, shining steadily and calmly. They are not in a hurry to change. Their light will continue to reach Earth for countless generations, providing a constant presence in the sky. The study of stellar evolution has revealed that even the most complex processes can be understood through simple principles: gravity, energy, and time. This simplicity adds to the sense of calm, showing that the universe operates in a consistent and reliable way. As you imagine the life cycle of stars, birth, stability, transformation, and release, it begins to feel less like a series of events and more like a gentle flow. Each stage leads naturally to the next, guided by forces that never rush and never pause. And within this flow, there is a quiet beauty. Stars do not resist their changes. They evolve, they transform, and they contribute to the galaxy in their own time. As the Milky Way continues its slow rotation, billions of stars are at different points in their lives. Some are just beginning, others are shining steadily, and some are nearing their final stages. Together, they create a dynamic yet peaceful system, a galaxy full of light, constantly renewing itself. And as you rest your thoughts on this quiet cycle, you can feel the calm rhythm of the universe, steady, continuous, and endlessly unfolding. As your thoughts continue to drift gently through the quiet brilliance of the Milky Way Galaxy, the life cycles of stars begin to feel less like isolated events and more like a continuous, flowing story, one where beginnings and endings are softly intertwined. Every star, no matter its size, contributes to this rhythm, shaping the galaxy in ways both visible and unseen. One of the more fascinating truths is that not all stars live alone. Many exist in pairs or even larger groups, forming binary or multiple star systems. In these systems, stars orbit each other slowly, their gravitational pull creating delicate, synchronized motions. Sometimes, as one star evolves, it can transfer material to its companion, creating a quiet exchange that alters both of their futures. In certain binary systems, this exchange can lead to something remarkable. If a dense remnant like a white dwarf pulls too much material from its partner, it can trigger a sudden burst of energy known as a Type Ia supernova. These events are incredibly bright, yet they occur far away, their light reaching us as a distant, silent glow. Another calming detail is that neutron stars, formed from the collapsed cores of massive stars, are among the most stable objects in the universe. Despite their incredible density, packing more mass than the Sun into a sphere only about 20 kilometers wide, they rotate with precise regularity. Some neutron stars, known as pulsars, emit beams of radiation that sweep across space like cosmic lighthouses. Their pulses so consistent that they can be used to measure time with extraordinary accuracy. There is also a quiet beauty in the existence of black holes formed from dying stars. Unlike the supermassive Sagittarius A at the galaxy's core, these stellar black holes are smaller, formed from individual stars that have reached the end of their lives. They do not roam aggressively or consume everything around them. Instead, they remain where they formed, quietly influencing nearby objects through gravity. Another gentle truth is that many stars end their lives without dramatic explosions. Red dwarfs, the most common type of star in the Milky Way, burn their fuel so slowly that none have yet reached the end of their life cycle since the universe began. These stars will continue to shine for trillions of years, far longer than the current age of the universe, offering a sense of enduring stability. As stars evolve, they also influence their surroundings. Stellar winds, streams of charged particles flowing outward, can shape nearby gas clouds, creating intricate patterns and cavities. These winds are not violent bursts, but steady flows, gently sculpting the interstellar medium over time. Another calming perspective is that even in their final stages, stars continue to provide light. White dwarfs glow softly as they cool, neutron stars emit steady pulses, and even black holes can be surrounded by glowing accretion disks when material falls toward them. Light in some form continues to emerge. There are also rare and exotic objects formed from stellar remnants. Magnetars, for example, are neutron stars with extremely strong magnetic fields. These fields can influence space around them in subtle ways, yet even they exist within the same overarching calm of the galaxy. Another soothing truth is that the death of a star is not an end in the traditional sense. The material it releases becomes part of the galaxy, eventually contributing to new stars, planets, and systems. In this way, the life cycle of stars is not linear but circular, an ongoing process without a final conclusion. The elements created in stars are particularly important. Heavy elements like iron, gold, and uranium are formed in the most extreme conditions, often during supernovae. These elements are then scattered across the galaxy, becoming part of new cosmic structures. Even the most precious materials on Earth have their origins in these distant stellar events. Another gentle detail is that the timing of stellar evolution varies widely. While massive stars may live for only a few million years, smaller stars can persist for trillions. This variation creates a layered galaxy, where stars of different ages coexist, each contributing to the overall balance. There is also a quiet harmony in the way stellar remnants interact with their surroundings. Neutron stars and black holes may attract nearby material, forming accretion disks that glow softly as matter spirals inward. These processes are steady and continuous, not abrupt or chaotic. Another calming truth is that the Milky Way contains countless stellar remnants, white dwarfs, neutron stars, and black holes, each marking the end of a star's journey. These remnants are scattered throughout the galaxy, quietly existing as part of its structure. As you imagine these remnants, dense, compact, and enduring, it becomes clear that even in endings, there is stability. These objects do not disappear. They persist, continuing to influence the galaxy in subtle ways. There is also a sense of connection in knowing that our own sun will one day follow this path. Billions of years from now, it will expand into a red giant, shed its outer layers, and become a white dwarf. This future is not something sudden or alarming. It is part of a natural, predictable process that unfolds slowly over immense timescales. Another peaceful perspective is that the light from stars carries information about their lives. By studying this light, scientists can determine a star's age, composition, and stage of evolution. In this way, the galaxy tells its story through the light it emits. The Milky Way, filled with stars at every stage of life, becomes a kind of living system, constantly evolving, yet always balanced. New stars are born as old ones fade, maintaining a steady flow of energy and matter. As your thoughts settle into this rhythm, the life and death of stars begin to feel less like opposites and more like parts of the same process. Creation and transformation are not separate. They are connected, flowing into one another without interruption. And within this flow, there is a quiet reassurance. Nothing is wasted. Nothing is truly lost. Everything becomes part of something new. As the galaxy continues its slow, steady motion, stars will continue to live, evolve, and transform. Their light will travel across space. Their remnants will shape new beginnings, and the cycle will carry on calm, continuous, and endless. And as you rest your mind on this gentle cycle, you can feel the quiet rhythm of the universe once more, steady, patient, and infinitely unfolding. Chapter 7, The Milky Way's Ancient History. As your thoughts drift gently backward through time, far beyond the present moment, the Milky Way Galaxy begins to feel less like a fixed structure and more like a story, one that has been unfolding quietly for nearly the entire age of the universe. The stars you see tonight are not just points of light. They are remnants of an ancient past, each carrying echoes of how the galaxy slowly came to be. In the beginning, there was no Milky Way as we know it today. Shortly after the Big Bang, the universe was filled with a hot, dense mixture of particles. Over time, as the universe expanded and cooled, these particles began to form simple atoms, mostly hydrogen and helium. These elements became the raw material for everything that would follow. One of the most calming truths about this early time is that structure did not appear suddenly. Instead, it emerged gradually. Tiny fluctuations in density, barely noticeable differences in the distribution of matter, began to grow under the influence of gravity. Over millions of years, these small variations slowly gathered more material, forming the first seeds of galaxies. The Milky Way likely began as a collection of smaller protogalaxies, early structures made of gas, dark matter, and the first generations of stars. These proto-galaxies did not form in isolation. They moved, interacted, and gradually merged, building up the larger structure we now recognize as our galaxy. Another gentle truth is that this process of merging was not chaotic in the way we might imagine. While there were interactions and collisions, they unfolded over vast stretches of time, allowing structures to settle and reorganize. The result was a gradual layering of stars and material, forming the Milky Way piece by piece. Some of the oldest stars in the galaxy still exist today, quietly orbiting in the halo that surrounds the galactic disk. These stars are incredibly ancient, with ages close to 13 billion years. They are like living fossils, preserving the conditions of the early universe within their composition. Another calming detail is that these ancient stars contain very few heavy elements. Because they formed so early, before multiple generations of stars had enriched the galaxy, they are composed mostly of hydrogen and helium. This makes them distinct from younger stars, which contain a wider variety of elements. As the Milky Way grew, it began to take on a more defined structure. A central bulge formed, surrounded by a rotating disk. Within this disk, gas settled into a thin plane, gradually forming the spiral arms that we see today. This transformation was slow and steady, guided by gravity and angular momentum. Another soothing truth is that the Milky Way has continued to evolve even after its initial formation. It has absorbed smaller galaxies, incorporating their stars into its own structure. These events leave behind subtle traces, streams of stars that move together, remnants of galaxies that no longer exist as separate entities. One such example is the Sagittarius dwarf galaxy, a small galaxy that is currently being gradually absorbed by the Milky Way. Its stars are stretched into long streams that wrap around the galaxy, slowly blending into the larger system. Despite these interactions, the overall structure of the Milky Way remains stable. Its spiral arms persist, its stars continue their orbits, and its central regions remain anchored. This stability is one of the most comforting aspects of its history, a sense that even through change, there is continuity. Another gentle perspective is that time in the galaxy moves differently than we are used to. Events that seem dramatic, such as the merging of galaxies, occur over hundreds of millions or even billions of years. From our point of view, everything appears calm and unchanging, even though slow transformations are always underway. The formation of the Milky Way also involved the gradual accumulation of gas. As the galaxy grew, it pulled in additional material from its surroundings. This gas settled into the disk, fueling the formation of new stars and helping to shape the spiral structure. Another calming truth is that the galaxy did not form all at once. Different regions formed at different times. The halo and bulge contain older stars, while the disk and spiral arms host younger stars. This layered structure reflects the galaxy's long and complex history. There is also a quiet beauty in the idea that the Milky Way has a memory, not in a conscious sense, but in the patterns of its stars and the distribution of its elements. By studying these patterns, scientists can reconstruct the galaxy's past, tracing how it formed and evolved over time. Another soothing detail is that the processes that built the Milky Way are still ongoing. Even now, the galaxy continues to interact with its surroundings, slowly evolving. It is not a finished structure, but a living system, constantly shaped by time. As you imagine this ancient history, the gradual gathering of matter, the merging of smaller galaxies, the slow formation of stars, it becomes easier to feel the depth of time within the Milky Way. Every star, every orbit, every cloud of gas carries a piece of that history. And within that history, there is a sense of calm. Nothing happened suddenly. Everything unfolded step by step, guided by simple forces acting over immense spans of time. The Milky Way did not rush to become what it is. It grew slowly, patiently, forming the structure we now call home. And as you rest your thoughts on this ancient past, you can imagine the galaxy as it once was, smaller, dimmer, still forming, gradually becoming the vast and luminous system we see today. As your thoughts continue to drift gently backward through time, the story of the Milky Way Galaxy begins to feel even deeper, layered with quiet events that unfolded long before the Sun, before Earth, before anything familiar existed. The galaxy you know today is only the latest chapter in a story that has been written slowly across billions of years. One of the more peaceful truths about this ancient history is that much of it is still preserved, not in words or images, but in the motions of stars. When astronomers observe how stars move, how they orbit, how they cluster, they can uncover traces of past events. These motions act like gentle echoes, revealing where stars may have originated and how they became part of the Milky Way. Among these clues are stellar streams, long, faint trails of stars that stretch across the sky. These streams are the remnants of smaller galaxies that were gradually pulled apart by the Milky Way's gravity. Over time, their stars spread out, forming delicate arcs that still carry the memory of their original structure. One of the most well-known examples is the Sagittarius Stream, a vast ribbon of stars that wraps around the galaxy. It originates from the Sagittarius dwarf galaxy, which is currently being slowly absorbed. This process has been ongoing for billions of years and continues even now, quietly adding new stars to the Milky Way. Another calming detail is that these mergers do not destroy the galaxy. Instead, they contribute to its growth. Each absorbed galaxy brings with it stars, gas, and dark matter, enriching the Milky Way and shaping its structure. It is less like a collision and more like a gradual blending. There is also evidence that the Milky Way experienced a significant merger early in its history, sometimes referred to as the Gaia-Enceladus event. During this period, a relatively large galaxy merged with the young Milky Way, contributing a substantial number of stars to its halo. Many of these stars still orbit in elongated paths, distinct from the more circular orbits of stars formed within the galaxy. Another soothing truth is that even these large-scale events unfolded slowly. The merging of galaxies can take hundreds of millions of years, allowing time for structures to adjust and settle. The result is not chaos, but a new equilibrium, a slightly altered, yet still stable system. The Milky Way's halo, which surrounds the visible disk, is one of the oldest parts of the galaxy. It contains ancient stars and globular clusters that formed during the earliest stages of galactic evolution. These clusters are densely packed and incredibly old, some nearly as old as the universe itself. Another gentle perspective is that the chemical composition of stars acts like a record of time. Older stars contain fewer heavy elements, while younger stars are richer in elements produced by previous generations. By studying these compositions, astronomers can trace the sequence of star formation and understand how the galaxy evolved. There is also a quiet story told by the Milky Way's central bulge. This region contains a mix of stars with different ages and compositions, suggesting that it formed through a combination of early rapid star formation and later interactions. Its structure, slightly elongated rather than perfectly spherical, hints at the dynamic processes that shaped it. Another calming truth is that the galaxy's spiral arms are relatively young compared to its halo and bulge. These arms are constantly forming and dissolving over time, shaped by density waves and the movement of stars and gas. This means that the Milky Way's current appearance is only temporary, a snapshot within a much longer story. The Sun itself is a relatively recent addition to this history, forming about 4.6 billion years ago in one of the galaxy's spiral arms. It was born from material that had already been enriched by countless generations of stars. In this way, the Sun and everything around it is part of a much larger lineage. Another soothing detail is that the Milky Way has likely consumed dozens, if not hundreds, of smaller galaxies over its lifetime. Many of these have been fully integrated, their stars now indistinguishable from those formed within the galaxy. Others remain partially intact, orbiting as satellite galaxies. There is also a sense of quiet continuity in the way the galaxy evolves. While individual stars come and go, the overall structure persists. The Milky Way remains recognizable, even as its components change over time. Another gentle truth is that the galaxy's history is not something that has ended. It continues to evolve, slowly and steadily. New stars are forming, old stars are fading, and interactions with other galaxies are ongoing. The story is still being written. The study of this ancient history has been made possible by missions like Gaia, which has mapped the positions and motions of over 1 billion stars. This data allows scientists to reconstruct the galaxy's past with remarkable detail, revealing patterns that were once invisible. Another calming perspective is that the Milky Way's past is not chaotic or random. It follows patterns, mergers, star formation, evolution that repeat across the universe. This consistency creates a sense of order, even in the vastness of time. As you imagine these ancient events, the slow merging of galaxies, the formation of stars, the quiet drifting of stellar streams, it becomes easier to feel the depth and continuity of the Milky Way's story. It is not a static object, but a living system shaped by time and motion. And within that system, there is a sense of peace. Everything unfolds gradually. Nothing is rushed. The galaxy grows, evolves, and adapts, all within the steady flow of cosmic time. As your thoughts settle, you can picture the Milky Way not just as it is now, but as it has been, changing, expanding, quietly becoming what it is today. And as it continues its journey through the universe, its history remains embedded within it, carried forward by every star, every orbit, every faint stream of light. Chapter 8: Strange Objects Lurking in the Dark. As your thoughts drift quietly through the vast and dim regions of the Milky Way Galaxy, far from the bright glow of familiar stars, you begin to notice that not everything in the galaxy shines. Some of the most fascinating objects remain hidden in darkness, subtle, quiet, and often invisible unless you know how to look for them. One of the most intriguing truths about the Milky Way is that it is filled with objects that do not emit visible light at all. These objects reveal themselves not through brightness, but through their influence, how they bend light, disturb nearby stars, or quietly emit energy in wavelengths beyond human vision. Among the most well-known of these are black holes. While the supermassive Sagittarius A rests at the galaxy's core, there are also countless smaller black holes scattered throughout the Milky Way. These stellar black holes are formed when massive stars collapse at the end of their lives, leaving behind regions of space where gravity is so strong that not even light can escape. Despite their mysterious nature, black holes are not chaotic or destructive forces moving randomly through space. Most remain where they formed, quietly orbiting within the galaxy, often unnoticed unless they interact with nearby matter. When gas or dust drifts too close, it can form a glowing accretion disk around the black hole, emitting X-rays that allow astronomers to detect its presence. Another gentle truth is that not all strange objects are massive. Some are incredibly small, yet equally fascinating. Neutron stars, for example, are the remnants of massive stars that have collapsed into incredibly dense objects. A single teaspoon of neutron star material would weigh billions of tons. Yet these objects are only about 20 kilometers across. Some neutron stars are known as pulsars. They rotate rapidly, emitting beams of radiation from their magnetic poles. As these beams sweep across space, they create a rhythmic pulsing signal, like a distant lighthouse. These pulses are so regular that they can be used as cosmic clocks, marking time with astonishing precision. Another calming detail is that many of these objects exist quietly, without dramatic activity. A neutron star may simply rotate, emitting faint radiation, while a black hole may remain dormant for millions of years. Their presence is subtle, their influence steady. There are also objects known as brown dwarfs, sometimes called failed stars. These objects form like stars, from collapsing clouds of gas, but they do not have enough mass to sustain nuclear fusion. As a result, they glow faintly, mostly in infrared light, and are often difficult to detect. Another soothing truth is that the Milky Way also contains vast regions of darkness, areas where dense clouds of dust block the light from stars behind them. These dark nebulae appear as shadows against the brighter background of the galaxy. Yet within these shadows, new stars are often forming, hidden from view. There are also rogue planets, planets that do not orbit any star. These objects drift freely through the galaxy, moving silently through interstellar space. They may have formed in planetary systems and later been ejected, or they may have formed independently from collapsing gas clouds. In either case, they exist alone, cold and dark, yet still part of the galaxy structure. Another fascinating truth is that some stars themselves can become invisible in certain ways. White dwarfs, for example, are small and faint, often difficult to detect unless they are close to us. Over time, they cool and fade, eventually becoming black dwarfs, objects that no longer emit significant light. However, the universe is not yet old enough for any black dwarfs to exist, making them a glimpse into a very distant future. There are also exotic systems where unusual combinations of objects exist together. For example, a neutron star orbiting a normal star can pull material from its companion, creating a bright X-ray source. These systems are rare, but they reveal the complex interactions that can occur in the galaxy. Another calming perspective is that even the strangest objects follow the same physical laws as everything else. Gravity, motion, and energy govern their behavior, creating a sense of order even in the most unusual circumstances. The Milky Way is also home to cosmic rays, high-energy particles that travel through space at nearly the speed of light. These particles originate from various sources, including supernovae and active regions near black holes. While they sound intense, they pass through space quietly, often unnoticed. Another gentle truth is that much of what we know about these objects comes from observing light beyond the visible spectrum. Infrared, radio waves, X-rays, and gamma rays reveal details that cannot be seen with the naked eye. In this way, the galaxy has layers of visibility, each revealing a different aspect of its structure. There are also regions where stars are so faint and sparse that the sky would appear almost empty. These areas, though less dramatic, are just as important to the overall balance of the galaxy. They provide space for motion, for expansion, for quiet. Another soothing detail is that even in the darkest parts of the Milky Way, there is always something present: gas, dust, or unseen objects. True emptiness is rare. The galaxy is filled with subtle forms of matter, creating a continuous, interconnected system. As you imagine these strange and hidden objects, black holes quietly orbiting, neutron stars pulsing steadily, rogue planets drifting through darkness, it becomes clear that the Milky Way is far more than what we can see. It is a layered, complex environment, filled with both light and shadow. And yet, despite this complexity, there is no sense of chaos. Everything exists within a framework of balance, guided by forces that remain constant across the galaxy. As your thoughts settle into this darker side of the Milky Way, you may begin to feel a quiet curiosity, a sense that even the unseen parts of the universe have their own calm and steady presence. And within that presence, the galaxy continues its gentle motion, carrying both light and darkness together in perfect balance. Another gentle truth is that the Milky Way's darkness allows us to see the universe beyond. Without the contrast provided by dark regions, the light of distant stars and galaxies would be harder to distinguish. In this way, darkness enhances visibility, creating balance between light and shadow. The study of these strange objects often requires instruments that can detect subtle signals: radio telescopes, X-ray observatories, and infrared detectors. Through these tools, scientists can see what is otherwise hidden, revealing the quiet complexity of the galaxy. Another calming perspective is that the unknown is not something to fear. The presence of mysterious objects and unseen forces adds depth to the universe, making it richer and more intriguing. The Milky Way is not fully understood, and that is part of what makes it so fascinating. As you imagine these hidden objects, silent black holes, pulsing neutron stars, drifting planets, it becomes clear that the galaxy is layered with both the seen and the unseen. Each layer adds to the whole, creating a system that is both complex and harmonious. And within this harmony, there is a quiet reassurance. Nothing is out of place. Even the strangest objects have their role, their position, their purpose within the larger structure. As your thoughts settle, the darkness of the Milky Way begins to feel less like an absence and more like a presence. Soft, expansive, and full of quiet possibilities. The galaxy continues its slow rotation, carrying with it both light and shadow, known and unknown, all moving together in a steady and peaceful flow. And as you rest within that flow, you can simply drift, knowing that even in the darkest corners of the universe, there is balance, structure, and a quiet, enduring calm. Chapter 9: Our Place in the Cosmic Neighborhood. As your thoughts gently return from the deep and distant corners of the Milky Way Galaxy, they begin to settle closer to home, toward the small region where our own star quietly shines. After exploring vast structures and ancient histories, there is something calming about narrowing your focus, about understanding exactly where you are within this immense system. Our home is not at the center of the galaxy, nor at its farthest edge. Instead, it rests in a quiet, unremarkable region known as the Orion Arm, a minor spiral arm located between two larger ones. This position is, in many ways, ideal. It is far enough from the crowded, energetic center to avoid intense radiation, yet close enough to benefit from the galaxy's rich supply of stars and elements. At the heart of our local environment is the Sun, a steady, middle-aged star that has been shining for billions of years. It is not particularly large or bright compared to other stars in the Milky Way, yet it provides exactly the conditions needed for life on Earth. Its stability is one of the quiet reasons why life has been able to develop and persist. Another soothing truth is that our solar system orbits the center of the galaxy at a comfortable distance of about 26,000 light-years. This distance places us in what some scientists call the galactic habitable zone, a region where conditions are relatively stable and less prone to extreme events like frequent supernovae. The solar system itself is a small and orderly system within this vast galaxy. Planets orbit the Sun in predictable paths, following the same gravitational principles that govern the motion of stars. This consistency creates a sense of calm, a reminder that even within the immense scale of the Milky Way, local systems can remain stable and balanced. Another gentle detail is that our Sun is just one of hundreds of billions of stars in the galaxy. And yet, it is the only one we know that hosts life. This makes our position both ordinary and extraordinary at the same time, ordinary in its location but unique in its outcome. Beyond our solar system lies a region known as the local bubble, a cavity in the interstellar medium filled with hot, low-density gas. This bubble was likely formed by ancient supernovae that occurred millions of years ago. Today, it provides a relatively shaন্ত environment, with less dense gas compared to surrounding regions. Another calming perspective is that our nearest stellar neighbor, Proxima Centauri, is still about 4.24 light-years away. Even at the speed of light, it would take over 4 years to reach it. This vast distance between stars highlights just how spacious the galaxy truly is. There are also other nearby stars, such as those in the Alpha Centauri system, which form a small cluster of stars relatively close to us. These stars, like our Sun, have their own histories, their own potential planetary systems, and their own quiet presence within the galaxy. Another soothing truth is that the Milky Way is not an isolated system. It is part of a larger collection of galaxies known as the Local Group. Among these galaxies is the Andromeda Galaxy, a massive spiral galaxy that is slowly approaching us. Though this future interaction is billions of years away, it reminds us that even galaxies exist within a broader cosmic neighborhood. Another calming detail is that the night sky we see from Earth is shaped by our position within the galaxy. The band of the Milky Way appears brighter in certain directions because we are looking toward denser regions of stars. In other directions, the sky appears darker, revealing the vastness beyond. There is also a quiet beauty in the way Earth is positioned within the solar system. It orbits the Sun at just the right distance to allow liquid water to exist, a condition that is essential for life as we know it. This region is often referred to as the habitable zone, where temperatures are neither too hot nor too cold. Another gentle truth is that the solar system is not perfectly still. It moves through the galaxy along with the Sun, carrying Earth and everything on it through space. This motion is smooth and continuous, part of the larger rotation of the Milky Way. The stars you see in the night sky are part of our local neighborhood within the galaxy. Some are relatively close, while others are much farther away. Their brightness depends not only on their distance but also on their size and energy output. Another soothing perspective is that constellations, the patterns we see in the sky, are not fixed structures. The stars that form them are at different distances and moving in different directions. Over long periods of time, these patterns will change, though the changes are too slow to notice within a single lifetime. There are also interstellar clouds within our neighborhood, regions of gas and dust that drift between stars. Some of these clouds may one day collapse to form new stars, continuing the cycle of creation within the galaxy. Another calming truth is that our location in the Milky Way has allowed us to observe the universe clearly. We are not blocked by dense clouds of gas, nor overwhelmed by intense radiation. This clarity has made it possible for humans to study the stars, to map the galaxy, and to understand our place within it. As you imagine your position within the Milky Way, on a small planet orbiting a modest star, located in a quiet spiral arm, it becomes easier to feel both grounded and connected. You are part of a vast system, yet you are also in a place of relative calm and stability. And within that balance, there is a quiet reassurance. The galaxy is immense, but your place within it is steady, predictable, and gently carried along by the same forces that guide everything else. As your thoughts settle, you can picture the Milky Way stretching above you, its stars glowing softly, its structure vast and intricate, and within it, your position remains constant, a small, calm point within a much larger whole. As your thoughts continue to rest gently within the familiar region of the Milky Way Galaxy, your sense of place begins to expand, not outward into overwhelming vastness, but outward into quiet connection. What once felt like distance now feels like relationship, as if every star, every neighboring system, is part of a calm and interconnected neighborhood. One of the most soothing truths is that our position in the galaxy is not just random, but remarkably stable. The Sun follows a nearly circular orbit around the galactic center, avoiding the more chaotic regions closer to the core. This stability has allowed life on Earth to evolve over billions of years without frequent disruptions from intense cosmic events. The solar system is also tilted slightly relative to the galactic plane, which gives us a clearer view of the universe beyond. Without this tilt, dense regions of gas and dust might obscure our observations, limiting our ability to see distant stars and galaxies. Instead, we have a window, quiet, clear, and expansive. Another gentle detail is that our local region of space is relatively calm compared to other parts of the galaxy. There are no nearby supermassive black holes actively feeding, no frequent supernovae explosions in our immediate vicinity, and no dense star clusters crowding our sky. This calmness has created a kind of cosmic shelter, a place where conditions remain steady over long periods. There are also nearby stellar associations, loose groups of stars that formed around the same time and still travel together through space. These associations are part of our extended neighborhood, moving slowly and quietly within the galaxy. Another calming truth is that the distances between stars, though vast, create a kind of natural spacing that prevents frequent interactions. Stars rarely collide, and planetary systems remain largely undisturbed. This spacing contributes to the overall stability of the galaxy. Our closest neighbor, Proxima Centauri, is part of a larger system that includes Alpha Centauri A and B. These stars form a small group, gently orbiting each other over long periods. Though they are the nearest stars to us, they are still incredibly far away, emphasizing the quiet vastness of space. Another soothing perspective is that the Milky Way itself is part of a larger structure known as the local group. Alongside the Andromeda Galaxy and several smaller galaxies, it forms a gravitationally bound system that moves together through space. This group is, in turn, part of an even larger structure known as the Virgo supercluster, connecting us to a broader cosmic web. Another gentle truth is that even though galaxies move and interact, these processes unfold over billions of years. The future encounter between the Milky Way and Andromeda will not be a sudden event, but a slow merging of structures, where stars pass by each other without collision. It will be a transformation, not a disruption. There is also a quiet beauty in the fact that our night sky is shaped by our position. The constellations we see, the brightness of the Milky Way, even the visibility of distant galaxies, all depend on where we are. If we were located elsewhere in the galaxy, the sky might look entirely different. Another calming detail is that our solar system moves through the galaxy along with the Sun, carrying Earth through space at a steady pace. This motion is smooth and continuous, part of the larger rotation of the Milky Way. Even as we sit still, we are gently traveling through the galaxy. There are also interstellar visitors, objects that pass through our solar system from other parts of the galaxy. One such object, known as Oumuamua, was detected in 2017. It traveled through our system briefly before continuing its journey, a quiet reminder that the galaxy is interconnected. Another soothing truth is that the Milky Way provides a kind of cosmic context. It reminds us that while Earth may feel large and complex, it is part of something much greater. And within that greater structure, everything follows the same fundamental rules. The stars in our neighborhood also vary in age and composition. Some are older with fewer heavy elements, while others are younger and richer in material. This diversity reflects the ongoing process of star formation within the galaxy. Another calming perspective is that the Milky Way is not unique. There are countless other galaxies, each with their own stars, their own structures, their own histories. And yet, this is the one we know, the one we belong to. There is also a quiet reassurance in the predictability of our cosmic environment. The sun will continue to shine, the planets will continue their orbits, and the galaxy will continue its slow rotation. These patterns provide a sense of continuity, a rhythm that does not change suddenly. Another gentle truth is that our understanding of the galaxy has grown over time. Through observation and study, we have learned to map our position, to measure distances, and to understand the structure of the Milky Way. This knowledge connects us more deeply to the universe around us. As your thoughts settle into the sense of place, the vastness of the galaxy begins to feel less overwhelming and more comforting. You are not lost in space. You are located, positioned, part of a system that moves with quiet precision. And within that system, there is balance. Stars shine, planets orbit, galaxies drift, all following paths shaped by gravity and time. As you imagine the Milky Way stretching around you, its stars glowing softly in every direction, you can feel a quiet connection to it, not just as an observer, but as a participant, a small but real part of its ongoing story. And as the galaxy continues its slow, steady motion, you can simply rest within it, carried along by the same gentle forces that guide everything else. Chapter 10: The Future of the Milky Way. As your thoughts gently move forward through time, beyond the present moment and into what has not yet happened, the Milky Way Galaxy begins to feel less like a fixed place and more like a journey still unfolding. The galaxy you see today, calm, balanced, and slowly turning, will not remain exactly the same. And yet, the changes ahead will come with the same quiet patience that has shaped everything so far. One of the most comforting truths about the future of the Milky Way is that nothing will change suddenly. The galaxy evolves over billions of years, not moments. Every transformation, no matter how large, unfolds gradually, giving the entire system time to adjust, to settle, and to continue its steady motion. In the near cosmic future, millions to billions of years from now, the Milky Way will continue forming new stars. Though the rate of star formation has slowed compared to its early days, it has not stopped. Vast clouds of gas still drift within the spiral arms, slowly collapsing under gravity, giving birth to new stars that will shine for billions of years. Another gentle truth is that over time, the Milky Way will gradually change its appearance. As older stars fade and fewer new stars are formed, the galaxy may become less bright and more shant in tone. The vibrant blue glow of young stars will slowly give way to the warmer, softer light of older stars, giving the galaxy a more golden appearance. The spiral arms themselves are not permanent structures. Over long periods, they shift and evolve, shaped by the movement of stars and gas. In the distant future, the Milky Way's spiral pattern may become less distinct, transitioning into a smoother, more uniform shape. Another calming perspective is that the galaxy will continue to interact with its surroundings. One of the most significant future events involves the Andromeda Galaxy, which is slowly approaching us at a speed of about 110 kilometers per second. This approach has been ongoing for billions of years and will continue for billions more before any interaction occurs. When the two galaxies finally meet, around 4 to 5 billion years from now, it will not be a sudden collision, but a gradual merging. Another soothing truth is that even during this merger, the vast distances between stars mean that direct collisions will be extremely rare. Instead, the galaxies will pass through each other, their gravitational fields reshaping their structures over time. Stars will be gently redirected, their orbits altered, but the overall system will remain stable. As the Milky Way and Andromeda merge, they are expected to form a new, larger galaxy, sometimes referred to as Milkomeda. This new galaxy will likely have a more elliptical shape, with less defined spiral arms. It will be the result of billions of years of gradual interaction and adjustment. Another calming detail is that our solar system, if it still exists at that time, will simply follow along. Its orbit may shift, moving to a different region of the new galaxy, but it will remain bound by gravity, carried gently through the transformation. The Sun itself will also evolve during this period. In about 5 billion years, it will expand into a red giant, becoming much larger and brighter. This change will affect the inner planets, including Earth, but it will occur gradually over millions of years. Another gentle truth is that the galaxy will continue to age. As more stars reach the ends of their lives and fewer new stars are formed, the overall brightness of the galaxy will slowly decrease. The Milky Way will become quieter, its activity more subdued. There is also a sense of continuity in the way elements will continue to cycle through the galaxy. Even as stars die, they will release material that can form new stars, though at a slower rate. The process of creation will not stop entirely, it will simply become less frequent. Another soothing perspective is that the Milky Way's dark matter halo will remain largely unchanged. It will continue to provide the gravitational structure that holds the galaxy together, even as its visible components evolve. As the galaxy merges with Andromeda, their dark matter halos will also combine, forming a larger, more massive halo that surrounds the new galaxy. This unseen structure will continue to guide the motion of stars within it. Another calming detail is that the night sky, as seen from Earth or its future equivalent, will change gradually. As Andromeda grows larger in the sky, it will become a dominant feature, eventually stretching across the horizon. This transformation will take millions of years, unfolding slowly enough to feel almost imperceptible. There is also a quiet beauty in imagining this future sky. Two galaxies blending together, their stars intermingling, their structures reshaping. It is not a moment of destruction, but of transformation, a continuation of the galaxy's long story. Another gentle truth is that even beyond this merger, the galaxy will continue to evolve. Over trillions of years, star formation will eventually cease, leaving behind a population of long-lived stars and stellar remnants. The galaxy will grow dimmer, but it will remain. As you imagine this distant future, it becomes clear that the Milky Way's story does not have a sudden ending. It continues, slowly and steadily, shaped by the same forces that have guided it from the beginning. And within that future, there is a sense of calm. Nothing is rushed. Nothing is abrupt. Every change unfolds in its own time, part of a larger, ongoing journey. As your thoughts settle into this vision of what lies ahead, you can feel the same quiet rhythm that has carried the galaxy through billions of years, a rhythm that will continue long into the future. As your thoughts continue drifting forward, far beyond the present and into the deep future of the Milky Way Galaxy, time itself begins to feel softer, less like something that moves quickly and more like a vast, gentle current. The galaxy's future is not a sudden transformation, but a slow fading into quieter states, guided by the same steady laws that have shaped it since the beginning. After the gradual merging with the Andromeda Galaxy, the newly formed galaxy, often imagined as Milkomeda, will settle into a more rounded, elliptical shape. The once distinct spiral arms will fade, their structure smoothed out by billions of years of interaction. What remains will be a calmer, more uniform galaxy, its stars distributed in a soft, glowing halo. One of the most soothing truths about this stage is that motion will continue, but in a quieter way. Stars will still orbit, but their paths will be less organized into arms and more evenly spread. The galaxy will feel less structured, yet still balanced, like a system that has reached a kind of maturity. Another gentle truth is that star formation will continue to decline. Over time, the supply of cold gas, the raw material needed to form new stars, will become more limited. Without this fuel, fewer new stars will ignite. The galaxy will gradually transition from a place of active creation to one of quiet persistence. As billions more years pass, the stars that remain will mostly be long-lived, smaller stars, red dwarfs that burn slowly and steadily. These stars can shine for trillions of years, providing a faint but enduring light long after more massive stars have faded. Another calming detail is that stellar remnants will become more common. White dwarfs, neutron stars, and black holes will quietly populate the galaxy, marking the final stages of earlier stars. These objects will not disappear. They will remain, stable and enduring, part of the galaxy's long-term structure. There is also a quiet beauty in the idea that the galaxy will become darker, but not empty. Light will still exist, but it will be softer, more subtle. The bright, energetic phases of the galaxy will give way to a more jaunt state, a slow, steady glow rather than a vibrant brilliance. Another soothing perspective is that even as star formation slows, gravitational interactions will continue. Stars will occasionally pass near each other, gently altering their paths. Some may be ejected from the galaxy, drifting into intergalactic space, while others settle into new orbits. Over extremely long timescales, trillions of years, the galaxy will enter what scientists sometimes describe as a degenerate era. In this distant future, most stars will have evolved into remnants, and the galaxy will be dominated by objects like white dwarfs and black holes. Another gentle truth is that even in this era, motion will not stop. Objects will continue to orbit, interact, and evolve, though at a much slower pace. The galaxy will not become static. It will simply become quieter. There is also the possibility that black holes will play a more prominent role in the galaxy's future. Over immense periods of time, they may gradually merge with one another, forming larger black holes. These mergers will release gravitational waves, ripples in space-time that travel silently across the universe. Another calming detail is that even black holes are not eternal. According to current understanding, they may slowly lose energy through a process known as Hawking radiation, eventually evaporating over incredibly long timescales, far longer than the current age of the universe. This means that, in the farthest future, even the most enduring objects may fade. The galaxy itself may gradually lose its structure as stars drift apart and remnants dissipate. Yet this process is so slow that it feels almost timeless. Another soothing truth is that the Milky Way's future is not separate from the future of the universe. It is part of a larger story, one that includes the expansion of space itself. As the universe continues to expand, distant galaxies will move farther away, eventually becoming invisible from within our own. There is also a quiet comfort in knowing that these changes are beyond any human timescale. They will unfold over trillions upon trillions of years, so slowly that they do not disrupt the present moment. The night sky we see today will remain familiar for countless generations. Another gentle perspective is that the galaxy's future, like its past, is guided by simple principles. Gravity, energy, and time continue to shape everything, creating a sense of continuity across all eras. As you imagine this distant future, the fading of stars, the quiet persistence of remnants, the slow merging and drifting of galaxies, it becomes less about endings and more about transformation. Nothing truly disappears. It simply changes form, becoming part of the next stage of the universe. And within that transformation, there is a deep sense of calm. The Milky Way does not rush toward its future. It moves gently, steadily, following a path that has been unfolding since the beginning of time. As your thoughts settle, you can picture the galaxy far into the future, dim, quiet, yet still present. Its stars fewer, its light softer, but its structure still held together by the same invisible forces. And in that vision, there is peace. The galaxy continues, not as something fading away, but as something evolving, slowly, endlessly, carried forward by the quiet rhythm of the universe itself.